Hello everyone. Today we'll be going through IGCSE physics and main topic is forces and motion, and this video is on free fall. According to the syllabuses of Cambridge, Edexcel, EQA and Oxford, if you want to go through the complete topic, which is forces and motion, it is covered in 6 videos which are available in the playlist. You can go through all of them. Now, understanding free fall. Free fall is what? Free fall describes the motion of an object when gravity is the only force acting on it. In this state, the object accelerates downward at a constant rate, giving it a predictable and uniform motion. So, in free fall, motion of the object is under the gravity only. What is free fall? Free fall occurs when gravity is the only force acting. No air resistance is considered in ideal free fall. Object accelerates downward continuously, so it's continuous acceleration, and motion follows predictable patterns common in physics models and calculations. So we are taking negligible air resistance. We are not counting that one, and we are simplifying our problems to understand better. Free fall is a special type of motion where gravity acts alone. Alone, there's no other force. So, without any opposing forces, this makes the objects accelerate downwards in a smooth, predictable way. Next thing which we can go through is acceleration due to gravity. On Earth, gravitational acceleration is about 9.8 meter per second square. Acceleration stays constant throughout the free fall. Speed increases by roughly 10 meter per second every second. So all objects accelerate at the same rate in free fall. Mass do not affect gravitational acceleration. So heavier objects are reaching to the ground if they are thrown from a equal distance, so they are reaching to the earth at the same time. Gravity at gravity accelerates all objects at the same rate, no matter their mass. This this constant acceleration causes speed to increase steadily every second during the free fall. So objects having different masses will be reaching to the earth at the same time, as example also. Then we can discuss the speed and velocity in free fall. Velocity increases continuously. This is what we discussed earlier also, as object is falling. So no maximum speed in ideal free fall. There's no maximum speed in ideal free fall condition, and direction of motion is always downward because its gravity is towards the earth, or it's towards the planet, whatever we are considering. Falling distance increases rapidly with time. Speed time graph is a straight line. It's basically a graph is a straight upward sloping line, so it's passing to the origin, and we have shown the velocity time graph also. And a free fall velocity rises at a constant rate because the acceleration never changes. This creates a straight line speed time graph that shows steady uniform acceleration. Further, we can discuss the graph of a free fall. Like example, we can take like paratrooper is jumping from the plane. So in real life, with air resistance, this is with air resistance. So real objects experience air resistance. Air resistance opposes downward motion. So acceleration reduces as speed increases. In the graph, you can see at 1, 2, 3. So it's decreasing the speed time graph for complete parachute jump from a small aircraft. So for the first section, this one speed is acceleration is decreasing and the speed is increasing. And then skydiving is a common example. Terminal velocity is reached when forces balance. So from 3 onward up to this position, the horizontal line is giving the terminal velocity, and this is the terminal velocity shown with the horizontal line. And at this point on 5, the paratrooper is opening his parachute, and suddenly the speed decreases and it reaches to a new level. 7 to 8 is basically the new horizontal, new terminal velocity. So its first terminal velocity is this one, and second terminal velocity is this one. In real situations, air resistance pushes upward and slows the acceleration of a falling object. Eventually, the forces balance and the object reaches a constant speed called terminal velocity. How to calculate the calculations, how we are making calculations in free fall? We are using G value as 9.8 meter per second square, or roughly we can take 10 meter per second square. And for speed after time t is equal, t will be what? V will be equal to G into T. Distance fallen will be S is equal to half GT square. And calculations assume no air resistance. We are considering um, without resistance. So useful for estimating motion near Earth's surfaces. So these are the equations which we are using. V is equal to gt and h is equal to half gt square, where h is height traveled, b is final velocity, g is acceleration due to gravity, and t is time taken. So free fall calculations rely on simple formulas that use time and gravitational acceleration. These equations help us predict how fast an object will fall and how far it will travel. So we are done with the video. Again, the main topic is forces in motion, which is covered in 6 videos, and these 6 videos are available in the playlist. You can go through all 6 videos to cover this topic. Thank you very much for watching. Take care. Bye.